Here we're going to have a look at stereoisomerism, and in particular EZ isomers. Stereoisomerism can be defined as molecules of the same structural formula but different arrangements in space of some atoms. EZ isomerism is specific to alkenes due to the restricted rotation around the carbon-carbon double bond. Let's just explain what that means. Consider I've got the following molecule. And we've got here 1,2-dichloroethane. And here I've written the two chlorines above the carbon chain. Because there's a rotation around this single bond, this molecule could easily be written as the following. And these molecules are in fact the same. Here I've written the chlorines above and below the carbon chain. Those molecules are exactly the same. 1,2-dichloroethane. Consider the next molecules that I'm going to draw. Here I'm going to draw 1,2-dichloroethene. And again, I'm going to draw the chlorines here above the carbon chain. But because there's a restricted rotation around this carbon-carbon double bond, then this molecule here is not the same as this molecule here. So here we've got the chlorine above and below, and these two molecules are different. They've got exactly the same structural formula, that is, the bonding between the atoms is the same, but the arrangements in space of these chlorines is different. And these molecules here that I've written are in fact EZ isomers. Which is the E and which is the Z isomer is what we're going to have a look at now. Before we just have a look at how we can label an isomer as an E or a Z isomer, what are the conditions required for EZ isomerism? Well, again, let's just draw a typical alkene. When doing so, it's a good idea to draw your carbon-carbon double bond and then 4 bonds with 120-degree bond angles here and here. Now let's consider we've got, for example, but1ene. I'm going to label this carbon A and this carbon B. Now in order for geometrical or EZ isomerism to occur, then the carbons A and B must have different groups attached. Now carbon B is fine because we've got different groups attached. We've got a hydrogen here and a CH2CH3 here. But carbon A has got the same group attached. So if you have the same group attached to either of the carbons in the carbon-carbon double bond, you cannot exhibit EZ isomerism. So but1ene cannot exhibit EZ isomerism because carbon A has the same group attached. Let's just have a look now at another alkene. And let's have a look at putting a CH3 here, an F here, a Cl here, and a Br here. We assign molecules this E or Z isomer tag based on something called the Cahn-Ingold-Prelog rules. And this is what we're going to go over now. What we do is we look at the two carbons involved in the carbon-carbon double bond, and again I've labelled them A and B. I then look at carbon A, and I have to assign then a priority to the groups attached to carbon A. The priority is based on the atomic number of the atom bonded to the carbon in the double bond. So I look at the atom bonded to carbon A, and here I've got a carbon, and the atomic number of the atom bonded to carbon A here is 6. I then look at the other atom bonded to carbon A, and that's a fluorine, and that's got an atomic number 9. The higher the atomic number, we say then the higher priority that group has. So we say that this here has got a high priority, and this group here has a low priority. I then have a look at the other carbon, carbon B, and again I assign priority based on the atomic number of the atom bonded to carbon B. And here we've got a chlorine, and its atomic number is 17, and here I've got a bromine, atomic number of 35. Well, 35 is obviously higher than 17, so the bromine here has got a high priority. The chlorine has got a low priority. Now, I'm just going to draw an imaginary line here, and we say then that if the high priority groups here are on the same side of the double bond as they are here, we assign that then the Z isomer. So the Z isomer is when the high priority groups are on the same side. Of the carbon-carbon double bond. The E isomer is obviously then occurs when the high priority group are on the opposite side of the double bond. So let's have a look at another molecule and see if we can assign these Cahn-Ingold-Prelog rules to say whether we've got the E or Z isomer. So again, draw my carbon-carbon double bond and then my 4 bonds here. 120 degree bond angles here and here. Now, I'm going to put CH3 there, a hydrogen there, I'm going to put a CH3 there, and a CH2, CH3 group here. And again, I'm going to assign this carbon, carbon A, and this carbon B. Now the molecule, let's just see what the molecule is. Well, I've got my longest carbon chain is here, which is, let's just count, we've got 1, 2, 3, 4, 5. So it's pent. The carbon-carbon double bond is on number 2. Remember, that's got to have the lowest number. That's why I've numbered from left to right. And I've got a methyl group attached to carbon 3. So that would be 3-methyl pent 2-ene. But this will exhibit EZ isomerism because carbon A has got different groups, carbon B has got different groups. So let's have a look at whether this is the E or the Z isomer. So I have a look at carbon A and I assign a priority based on the atomic number of the atom bonded to carbon A. Well, here we've got a carbon bonded to carbon A with an atomic number of 6, and here we've got a hydrogen with an atomic number of 1. So this is my high priority group. So I'm going to label that high. And this is low. Now have a look at carbon B. And we can see that carbon B is a carbon attached above and a carbon attached below. It's a tie. Both of these are atomic number 6. What we do now is we move on to the next atom, the atom bonded to this carbon. And the atom bonded to this carbon, if we move along, is a hydrogen. And that there is an atomic number of 1. We then have a look at the atom bonded to this carbon, and that is another carbon, and that's got an atomic number of 6. So it's a tie at first, and then move on to the atom then bonded to the carbons there I've labelled 6. And we can see then that this then has a higher priority because 6 here has got a higher atomic number than 1. So let's label this one high and this one low. So again, I draw my imaginary line through the middle, and we can see here now that my high groups are opposite the double bond. So here we've got the E isomer. So this molecule here then we can label as E-3 methyl pent 2-ene. So they are the Cahn-Ingold-Prelog rules for assigning whether an isomer is an E isomer or the Z isomer.